Reader-writer problem is a classical synchronization process method example. Real life example is airline system. Whenever a user wants to visit the airline browser to see the availability of ticket, and whenever he books, then it is writer. In readers-writers problem, file is shared among the several concurrent processes. Few processes may want only to read from the shared data, and few processes wants to write. Suppose we classify the problem as readers only read the file data, said they do not perform any updates, and writer can do both read and write. We assume there are 5 processes P1, P2, P3, P4, P5, where P1, P4 are reader and P2, P3 and P5 are writers. So, reader-writer problem, real life example already I have told. Airline system, ticket booking system. Whenever we view the ticket availability, we are the reader. When we actually book the ticket, then we are the writer. Now, how the process synchronization implemented in this? First, we have to understand only one writer is allowed in critical section. If writer is writing, no reader or writer is allowed. Multiple readers may be allowed, but no critical section. If reader is reading, writer is not allowed. Otherwise, we will face a race condition. I think you have seen my video where I have discussed race condition. So, to implement readers-writers problem, we have to understand these 4 points. And whenever we implement semaphores to solve reader-writer problem, we have 3 variables. One is WRT, is a binary semaphore between the reader and writer. WRT equals to 1 for first and last reader. And another variable is read count. Read count is used for how many processes are currently reading file. Initially, read count equals to 0. And there is a mutex variable, which is a binary semaphore between the readers for updating the read count, and initial value mutex is 1. So, recap, we need 3 semaphore variables: WRT, read count and mutex to synchronize the reader-writer's problem. Thus, no race conditions will occur. Now, writer's logic is wait for the WRT semaphore, then perform writing operations and then signal the WRT. Whenever writers want to write, wait for the right semaphore. Then he or she can perform writing, and wherever complete, then he or she have to give a signal. So here we can use a infinite while loop within wait WRT, then writing is performed, and have to give a signal functions with WRT. This is the structure of the previous slide. Now seriously think that if reader is reading, writer is allowed or not? The answer is no. Now, if the writer is writing, reader is allowed? No. And if the writer is writing, writer is allowed? What will be the answer? No. And again, if reader is reading, reader is allowed? Answer is yes, because there may be more than one reader. So more than two readers can read at a time. Normal scenario, more readers are allowed. Now the structure of the reader process. The variables are same. Semaphore for updating read count is mutex, and read count is integer variable, and WRT is a semaphore variable. If some reader is reading, wait for mutex, increment read count, then signal the mutex. Remember that if it is the first reader, then wait for WRT, then wait for mutex to increment the read count, and then signal the mutex. But if it is the last reader, suppose in case of last reader, then again signal WRT. So this is the algorithm, or this is the step, this is the structure, we can say, of a reader process. Now, please read the slide very carefully. If needed, give pause. Now the structure of reader process we can write within a infinite while loop. Check, wait for mutex to increment, then increase the count, that means read count plus plus. If you are the first reader, then check WRT. If read count equals to 1, wait WRT. This is for the first reader. And signal mutex for other reader. So signal function mutex. Now you can perform the reading operation. So we have to decrement read count, wait for mutex, because one reader is in execution. So again wait mutex and read count minus minus, because we have to give the proper value of read count in decrement. If read count equals to 0, last reader, again we have to give a signal WRT. Those who have subscribed my channel, thank you. Otherwise, please subscribe and